All right, we're going to look at some second order inhomogeneous constant coefficient linear ODEs. This is an example. So we're just going to get to it and solve it. Our first task is to solve the associated homogeneous problem. That is YH double prime plus 4YH equals nothing. We know to sub YH equals e to the lambda t. So we get lambda squared plus 4 equals 0. That implies lambda equals plus or minus 2i. We've got the complex conjugate root case here. They're actually purely imaginary eigenvalues. So we get for our general solution okay, so that's really nice, straightforward. What we've got to do now is deal with the particular part. So that particular part is this e to the 3t. What we suppose when we're solving these equations is we always guess that y is the sum of the homogeneous part plus some particular part. We make the particular part look like the driving term. So g of t, our driving term, is e to the 3t. So we're going to guess our particular part is c naught e to the 3t, and we're going to try and find this c naught, this amplitude that makes everything work. So let's stick this into our equation. So our full ODE. Y double prime is actually fairly easy to compute in this case. Y homogeneous double prime, different second derivative of cosine is just minus cosine, so we're going to get a minus 4 from that frequency there. Minus 4 sine, it's a D. Plus 4 times C cos 2t plus 4d sine 2t. Now I'm going to get the second derivative of my exponential term. That's going to give me a plus 9, right? I get a 3 from the first time, and then I get a 3 again from the second time. All right, so I've had to go over 2 lines here. Firstly, what you see is that everything associated with homogeneous part cancels, as it should, right? The homogeneous problem is actually equal to 0, right? That's the linear operator on the homogeneous solution equals 0, right? And that's just what we've seen. We're left with, oops, there should be a C naught here, a C naught here, and there should be a e to the 3t there. Because we were subbing in here and that. So that is equal to 13 C naught e to the 3t, and it's very easy to see that this is equal to that C naught equals 1 over 13 in this case. So just to sort of clarify this, this is YH double prime there. This is for YH. This is YP double prime. This is for YP. Okay, so that's, you can see where all the bits are coming from. Right, so now we can construct our general solution to the inhomogeneous problem. All right, and if we had initial conditions, this would be the moment that we substitute them in. But we don't have them, so the best we can do is this general solution.